All right, so for this video, what we're going to do is we are going to learn about the loop function. In the previous video, we first learned about how to shift the logic from one of the LEDs, or in that case, one of the pins, over to the left one in order to make an LED light up in sequential order. In order to do that, in order to learn about the loop function, let's first boot up THRSim. And as we usually do, we just move these registers off to the side. Um, and we press File, Open, and then we'll just go to our old work from one of the tests. And as you can see, what we pulled up was just the standard LED, single LED, getting it to turn on from its initial off state. So we need to initialize our LEDs. I might pause, but I'll go by pretty quickly. What we're trying to do is we're trying to add 8 LEDs in order for them to light up like the project that we're assigned told us to do. So we have so far 1, 2, 3, 4, 5, 6. We need 2 more LEDs. There you go. Let's just press the tile tab just to have it all in nice order. And then we need to connect them to the individual pins. And it's instructional. When you are initializing, it's good to press OK and not the close button, because if you press the close button, then it will not save your work. So this is going to be pin 3 or LED 3, so it needs to be pin 2. And connect. Let me just double check that one. Yeah. And now for 4 connects to pin 3. And we're just going to keep going down the line. 5 goes to 4. And 6 goes to 5. And 7 goes to 6. And 8 goes to 7. All right, there you go. So now what we have right here, we have the LED. Well, let's just go over what the code does. We first initialize our variable, as told in the previous video. I believe it's video number 1. We have LED1 being equal or equivalent to the storage location or the register at $, which is hexadecimal, 1004. So that means that the LED is going to have the value sent by the register. Okay, let me word it like this. $1004 is just a register, and we feed data to that register, and it is equivalent to the pins, pin B or port B, I should say. So if you want to have a certain logic sent to port B, you need to use the register $1004. And we changed the name of it to LED1 just to make it more understandable. And then we have ORG, which is just starting the counter. And we chose to use C000. And what we're going to use is a load accumulator A. We're loading the number, the decimal number 1 to accumulator A. And then we're going to store that value using STAA to LED1. So the register of $1004 will have the decimal value of 1. I believe it might actually just be hexadecimal that's able to be stored in there, but the computer will automatically convert it if so. I need to actually figure that out through reading. But what we're concerned with is shifting the logic from one LED all the way to the last one. And how we're going to do that is through the loop function. So using a mix of the loop function and the LSL function. So as we learned the last time, the LSL will shift the logic from the one pin to the next one that's adjacent to it, and also to the left. So we have LSL shifting the logic from LED1 over to the left. And in order to do that, we're going to use, or all the way to the pin 8, we're going to use the loop function. So it's saying essentially that we are looping the logical shift to the left as many times as we need to be. But it is a little bit more complicated than that. What we do need to do, we need to first, essentially, we need to have some type of mechanism to tell your program how many times it's going to run the loop. And the way that we do that is by first initializing a number. Let's say we can store it in LDAB because you have two, as I can show you in here. We have LDAA, which is load accumulator A, and we have LDAB, which is load accumulator B. So we have another option. I don't know if we could also do it for two LEDAAs, because essentially we're taking the logic from the one over to the register. Maybe we can also do something with the LEDAA, but for this purpose, let's just use LDAB. We want to load a value into the accumulator B. What value? Well, we need to first see how many LEDs we have. So we have 8 LEDs, and we're trying to shift it over all the way to the leftmost one. So from 1 to 2, that's 1, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8. That is 7 shifts total in order to go from the first LED all the way to the 7th or the 8th one. So that means we need to load LDAB immediately. We need to do immediately the decimal value 7 to accumulator B. And we are going to basically -1 each time, -1 to the accumulator each time we loop. So the way we do that is through the function DEC B, because we're going to be decrementing the accumulator B by 1 each time it loops. And the way that we can confirm that is by looking at the lesson plan that we saw in class, in which we have just the basic loop. And he used DECA, but that's because he was decrementing LDAA. For the purposes of our code, we're doing LDAB. So we use DECB. We don't need to have anything else to that. We could just go on to the next code, where we want to see if the value in LDAB is equal to 0. And if it is, then it will terminate the code. If not, it will decrement it again. So the way we do that is through the DNE function, I believe, and looking back at it, yes. No, it's called BNE. And all it does, I need to see more of the functionality behind it, but the way it was described in class is that it will check to see if the value stored in LDAB is equivalent to 0. And if it's equivalent to 0, it will cut the circuit. But if it's not, then it will decrement it again. And the way that we end it is by having the loop end here. So essentially, we are storing a value, a decimal value 7, into LDAB. Then we begin the loop, which is shifting the logic to the left by 1. That's stored in LED1. And then it will decrement that value by 1. Essentially, it will signify that the loop has already completed one time. And then it will check to see if it's equivalent to 0. And if it is, then it will stop the loop. And if it isn't, then it will decrement it again, but also shift the logic to the left again. So essentially, what this means is that when I start the circuit, the light should go, or should be, to be honest, because it happens so quickly, at LED number 8 instantly. It should not, you should not be able to see it go from 1 to 2 to 3 to 4. But I will show you that it also works for those two. So if we run the code, as you guys can see, what we have right here is the 8th LED turned on. So it starts at LED number 1, which is this one. And through this code, it went all the way to LED number 8. How am I sure that it does that? By decreasing the decrement by 1, or by decreasing the load LDAB, the accumulated value at B, by 1. Let's say if we wanted to do 6, it will go through this loop 6 times. And instead of being at LED number 8, it will be at LED number 7. Now this is an instructive moment. In order for you to see this change, what you need to do is first reset your circuit, or reset the chip. It will say, do you want to reset the chip? You say yes. And then you get a memory warning. I need to figure out more about what this memory warning is, but for the purposes of this code, just press continue. And then you will press the start button, or the run button. And as you can see, following this, we now have it at LED number 7. Now, let me just do it one more time. If we decrease the value of B loaded, of the value loaded into B by 1, now it should be 6 that turns on. So first, we want to reset. Do you want to reset it? Yes. Ignore or continue the memory warning. And we want to close these tabs and press start. And as you can see, it goes down to LED 6. So yeah, essentially what it's doing is it's first starting at LED 1, and it's just going through all the motions until it reaches LED number 6, 7, 8, it doesn't really matter. Let me just do a little bit of experimenting. What if we had the value, let's say 1? Let's say we just had it 1. Would it be 2? Because then it will go through, decrease by 1, and then it would be at 2. So let's see. Yeah, that works. Okay. Now, how would I have it be at 1? LED or LDAA 1, TAA, LDAV. Okay. Well, in this purpose, I guess 1 will always be shown at least once, um, because it's starting at 1. So that means the LED 1 would initialize at 1. So, in the purposes of future videos, we're going to figure out how to slow this process down so that it doesn't instantly swap between the LEDs. And it can go from 1 to 2 to 3 to 4, and you'll visually be able to see that. But in the purposes of this video, it just shows you how to operate the loop. And that's about it. Thank you.